Hello, this is the section 2.4 lesson. In this lesson we're going to talk about an idea called equivalent fractions. We're going to start off by defining what are equivalent fractions, and then we're going to talk about why we might want to use equivalent fractions, and then we're going to show how we can use the idea of equivalent fractions to solve lots of different types of word problems. And in these word problems, we're going to be drawing a lot of pictures to solve them. We could solve these problems using some arithmetic like addition and multiplication. We're not going to do that. We're going to simply draw pictures to solve these problems. So first of all, the definition of equivalent fractions is fairly simple. Two fractions are said to be equivalent if they represent the same quantity. Okay, so what exactly does that mean? Let's look at a simple example. Well, the fraction 1/2 is equal to the fraction 2/4. That's something we may all know, but now the question is, why are they equal? Well, let's illustrate why they're equal using a simple picture. So let's draw a picture of the fraction 1/2. So the fraction 1/2 means we're going to take our whole, and let's just use this box here to represent the whole. 1/2 means we're going to divide that up into two equal pieces, and then we are going to select one of those pieces. So that piece right there represents 1/2. Okay. Now the fraction 2/4 means that we're going to take that same whole and divide it up into four equal pieces. So let's do that. We'll just draw a horizontal line there to divide that same whole up into four equal pieces, and then 2/4 says we're going to select two of those pieces. Well, we see that we've already selected two of those pieces, and so those same two pieces that we have selected represent 2/4. And so 2/4 equals 1/2. They represent the same quantity. It's the same pieces of the same whole. So that's what it means for two fractions to be equivalent, that they represent the same quantity. Now let's look at a simple example to illustrate why we might want to use equivalent fractions. So here's a simple question: which is larger, 2/3 or 3/5? Now there's lots of ways that we could answer this problem, but let's look at how we can draw pictures and use the idea of equivalent fractions to solve this problem. And so let's draw a picture of the fraction 2/3. So let's draw a simple box here to represent the whole. And 2/3 means we're going to divide that whole up into three equal pieces, and then we are going to select two of them. Okay. So those two pieces right there represent the fraction 2/3. Okay. Now the fraction 3/5 means that we're going to take that same whole, and so let's draw the same whole over here, and we're going to divide this up into five pieces. So let's draw horizontal lines here, 2, 3, 4 of them. So four equal pieces. They may not look real equal, but they're equal. And so we're going to select three of those pieces. So there's one piece, two pieces, and three pieces. Okay. So those three pieces right there represent the fraction 3/5. So now we can compare those pieces, or we can try to compare those pieces. So we might say, well, over here we've got two pieces, and over here we've got three pieces. Three pieces sounds like more than two pieces, but there's a problem in that these pieces are not the same size. Not only are these tall and skinny, whereas these are horizontal and skinny and skinnier, they don't represent the same quantity. Those pieces do not represent the same quantity. And so what we want to do is draw these pictures so that all the pieces are of the same size. Well, that's fairly easy to do. And so let's do this. Let's draw four horizontal lines over here, 2, 3, 4. So now we've broken this up into five horizontal pieces. And then let's draw two vertical pieces over here, two vertical lines like that. And so now let's look at each of these pictures. So now over here in this picture we have the whole that's divided up into three columns, and there's 5 in each column, so there's 15 pieces total in the whole there, and we have 5, 10 of those shaded, and so this fraction 2/3 is equal to the fraction 10/15. Okay? So So there we have come up with equivalent fractions, 2/3 and 10/15. Well, let's do the same thing over here in this picture. We see that again we've got 3 columns of 5 pieces in each column, so there's a total of 15 pieces. But now look how many pieces are shaded. We've got 3, 6, 9. Only 9 of them are shaded. So this fraction 3/5 is equal to the fraction 9/15. Okay. And so now let's compare these fractions 10/15 and 9/15. We can compare these two fractions because the pieces are all of the same size. All these pieces here are the same size as those pieces over here. So in this fraction we have more pieces than in this fraction over here, and so we would conclude that 10/15 is bigger than 9/15. And we can do that simply by looking at the pictures and comparing the number of pieces. And so because those fractions are equivalent, we can then conclude that 2/3, that's the fraction equivalent to 10/15, is bigger than 3/5. And so there's our final conclusion. 2/3 is bigger than 3/5. And we did that by using pictures, the meaning of fractions, and the idea of equivalent fractions. So now let's use this idea of equivalent fractions to solve some word problems. And so here's our first example. Suppose that you want to make a recipe that calls for 2/3 of a cup of flour, but you only have half of a cup of flour left. Assuming that you could make enough of the other ingredients, what fraction of the recipe can you make? So we've got two fractions here. We've got the 2/3 of a cup of flour, but we only have a half of a cup of flour. So let's draw pictures of those two fractions. So the 2/3, let's draw a rectangle here to represent our whole, which is a cup of flour. And it says that we have, that calls for 2/3 of a cup. So let's divide this up into 3 pieces, and let's select 2 of those pieces. Okay. So that right there is the 2/3 of a cup of flour that we need. Now let's draw a picture of the half of a cup of flour that we actually have. So again, our whole here is a cup of flour, but we only have a half of a cup. And so let's divide this up into 2 equal pieces and select one of those pieces. Okay. So now we have 2/3, or we need 2/3 of a cup, but we only have a half of a cup. So it looks like we need 2 pieces, but we only have 1 piece. But the problem that these pieces here are the different sizes as these pieces over here. So let's draw pieces of equal sizes. And we can do that very easily by drawing 1 horizontal line there and 2 vertical lines right here. So now all our pieces are of the same size. And so now we can see from this picture over here that we need a total of 4 pieces. 4 pieces. But over here we see that we only have 3 pieces. Okay. So we need 4 pieces, but we only have 3 pieces. So that means that we have, well, only 3 out of 4, or 3/5, or 3/4, excuse me, of what we need. So there we go. There's our answer. We only have 3/4 of what we need, so that means that we can only make 3/4 of the recipe. Here's another example dealing with measuring baking quantities. So first you poured 3/4 of a cup of water into an empty bowl. Then you scooped out half of the water in the bowl. How much water is left in the bowl? Now notice that we have 2 fractions here, 3/4 of a cup of water, and then it says we scooped out half of the water in the bowl. So let's draw a picture to illustrate what this is saying. And so let's draw a box here to represent our whole, which is a cup of water. And then it says we poured 3/4 of a cup of water into the empty bowl. So let's break this up into 4 pieces. And it says that we poured 3 of those pieces into the bowl. So there's our 3/4 that we poured into the bowl. But then it says we scooped out half of the water in the bowl. Now notice the hole here is not a cup. The hole is the water that's in the bowl. So this right here is our hole. We're dealing with a different hole here. And we got to be very careful that we understand that and then we recognize what the hole is. As we've stressed many times before, whenever we talk about fractions, we have to properly understand and define the hole. In this case, we've got two different holes. The first hole is a cup of water. The second hole is the water in the bowl. Okay? So it says we scoop out half of the water in the bowl. So let's take that water in the bowl, and in fact the whole cup of water, and let's divide that up into two equal pieces. Okay? And so that's going to take our whole there and divide it up into a piece here and a piece here. Well, really we should say 3 pieces here and 3 pieces here. So now we're going to scoop out half of that water. So let's say we scoop out that piece and that piece and that piece. And so what's left in the bowl is equal to, well, the 3 pieces on top. So we have 3 pieces left. And in the entire cup, we see that we have 8 pieces. So a total of 8 pieces that are in the cup. And so we have left 3/8 of a cup of water. So there's our answer. We have 3/8 of a cup of water that is left. Now let's do a similar example that at first glance looks almost identical to the previous example, but there's a slight difference, and that slight difference is very important. It says first you poured 3/5 of a water, 3/4 of a cup of water into an empty bowl. Then you scooped out 1/4 of a cup of water. How much water is left in the bowl? So again, we have two fractions here. We have 3/5 of a cup of water, and then we have 1/4 of a cup of water. Now notice that those two holes are the same. They're not different as they are in the previous problem. And so let's draw a picture to illustrate what we're doing here. So it says we poured 3/5 of a cup of water into an empty bowl. So here's a hole, which is a cup, and we poured 3/5 of a cup of water. So let's divide this up into 5 equal pieces by drawing 4 vertical lines. And then we're going to pour 3/5, 3 of those pieces into the bowl. So 1, 2, 3. So there's the 3 pieces that we're going to pour into the bowl. But now it says that we're going to scoop out 1/4 of a cup. So let's draw a picture of that. And so 1/4 means that we're going to divide the whole up into 4 pieces. So again, notice that we've got the same hole here, which is a cup. And so let's draw 3 horizontal lines here. So there's our 4 equal pieces, and so we're going to scoop out one of those pieces. Okay? So it's like we're going to pour 3 pieces of water into the bowl, and then we're going to scoop out one of those pieces. But we see that those pieces are not the same size, and so we need to get things of the same size. Well, we can do that very easily. Let's go over here and draw 4 horizontal lines, or excuse me, 3 horizontal lines. And then over here, let's draw 4 vertical lines. 1, 2, 3, 4. Okay. And so what we can see now is that we poured how many pieces? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we poured 12 pieces. And then we're going to scoop. And how many pieces do we have there? 1, 2, 3, 4, 5. So we're going to scoop 5 pieces. Okay? Now all those pieces are of the same size. And so that's very important. Whenever we're comparing fractions or doing things with different fractions, we have to have pieces of the same size. So we poured in 12 pieces. We're going to scoop out 5 pieces. And so let's X out the 5 pieces that we're going to scoop out. 1, 2, 3, 4, 5. And so what's left after we scoop out the 5 pieces is, well, what's left? We've got 1, 2, 3, 4, 5, 6, 7. So we've got 7 pieces left. Now how many pieces are in the hole? Well, we have 1, 2, 3, 4 rows and 1, 2, 3, 4, 5 columns, so we've got a total of 20 pieces in the whole, and so we've got left 7/20ths of a cup. So there's our answer. Right? So we started off by drawing our two fractions, 3/5 and 1/4. We noted that the pieces were not of the same size, and so we got equivalent fractions by making all the pieces of the same size. And so we said we poured in 12 pieces, we scooped out 5 pieces. When that was done, we were left with 7 pieces. We had 20 pieces in the whole, and so there's our answer, 7/20ths of a cup. So that's it for section 2.4. Your assignment before next class is to read section 2.4 from the textbook.